Thank you. Okay, we're recording again. So let me just start sharing my screen. And oops, I want to start with the slideshow. Um, Welcome everyone to Python level 2. So we completed level 1 and we're moving on to what we call level 2, although we're kind of just gonna continue like we did before. So the overall structure of the class is gonna be the same. We're gonna have a review and go over some homework at the beginning, have some sort of class time, and then give out the homework at the end. And then during the week, you work on that, and we do that for 8 classes. So today is a little bit of a special class because it is the first in the series. So I do want to take kind of a larger review, but it's going to be very quick, of just kind of everything we covered in Python level 1. So we know where we're like working from, right? And so I kind of came up with a list of topics, kind of the more important topics to remember, roughly in the order of we learned them. So the first is going over our data types. So in programming in Python, we have something called data types because our variables are of some sort of type. Maybe they're a number, they're an int. Maybe they're a true false value, a Boolean. Maybe they're a word or a sentence, that's a string. And there's a lot of other data types. Though in Python, we don't explicitly say it. So like a variable could be any sort of type and you can give it any sort of value, but you have to know like under the hood, behind the scenes, it actually does have a data type associated with it. And based on the data type, you can do different things with it, right? For a string, you can take a substring and get a part of the string. You can't do that for an integer, right? It just doesn't make sense. The second thing is lists. Lists, we said, was a little bit more of an advanced data type. It's kind of a collection of items, right? It's a collection of items that has a sort of ordering. So like you have a first position, you have a second position, you have a third position. Although we mentioned that instead of calling it first, second, third, we actually start at 0. So it's the 0th position at the beginning, and then it's the first, second, third. So that's the idea of indices, indexing things. Always start at 0, goes up to the length minus 1. And then we also talked about slices. So that's something that strings and lists share. You can take a slice of a string or a slice of a list, which means you kind of cut out part of it. And so slices looked like 1:4, for example. That's an example of a slice, where you start at index 1, you go up to, but not including index 4. So you take everything at index 1, 2, 3, and that's your slice. Third, we have user input. That's how you get, like, you want the person running the program to enter some sort of number or enter some sort of answer input. How do you do that? You use the input function. You just say input, maybe you give some sort of message, and then you get in the input. Next, conditions, which is your if, else if clauses. So whether you want to branch depending on some sort of condition, right? So if x is greater than 5, do this, else do something else, right? So it's like do one or the other. Finally, the last thing we covered last week actually was loops. So we mentioned 2 types of loops, for loops and while loops. And loops are used to repeat statements. You have some sort of code block. It's maybe 1 line of code, maybe it's 10, maybe it's 100, and you just want to repeat it a certain number of times. And that's where you use a loop. So I want to take kind of a break. These are just roughly 5 bullets that you should make sure that you understand before we move on to the new content in Python level 2. Does anyone have any questions about any of these bullets? I will say we're not going to be like quizzing you on these directly, However, you will need to understand this because we're just going to be using it in the level 2 material. That's why it's kind of like the next level. Also, just as a reminder, I think everyone should be a returning student, but just as a reminder, I'm very welcome to taking questions in any format. You can message me in Zoom chat, you can unmute, you can do anything you like. I'm happy to stop and answer questions anytime. Questions on the review. I do want to get started with kind of the new material because that's the more exciting part, I think. Before we do that, just really quickly, we will need some sort of Python editor to write Python code. Last Python level 1, we mostly use Google Colab, and I will be using that myself. Although in the 7th class, you did install PyCharm, which is a Python integrated development environment, IDE. And PyCharm is also very nice. I do use PyCharm when I'm programming by myself, but I think Google Colab's easier to just play around. So the choice is yours, but please take the time right now to maybe open up a new notebook or start up PyCharm. I know it takes a little bit of a while, so we can get started on that ahead of time. Let me actually do this. So for Python level 2, I have notebooks kind of pre-prepared. So I can give a link. This is just going to be a view link. I believe you might be able to run the cells, or you might be able to make a copy. Either way works. But that's kind of a notebook that's already prepared with everything we're going to cover today. But what are we going to cover today? That's going to be exception handling. So the first class is going to be, I think, not as exciting in terms of content, but is very useful. And definitely, this is something I use a lot when I'm programming in Python, because unfortunately, errors do happen. And the whole thing about exception handling is how do you handle when something goes wrong, right? We've seen this happen before. We've seen programs fail in Python level 1. And in Python level 1, we just said, okay, the program crashes, it stops, we will just fix it ourselves in the code, right? But what if we want the program, instead of just crashing, right? Like when you're using some software that someone else wrote, you don't want it just to randomly crash on you. You want it to tell you, hey, you did this wrong, please try again, something like that, right? So how do we do that in Python? First, though, what causes exceptions, right? Where do these things happen? The answer is technically everywhere, but we're just going to investigate one example to start off with. We have these 2 lines of code that is kind of something we've seen in Python level 1. First of all, can anyone tell me why do we have the int here? Why do we need this int? Right, we say, please enter an integer. Why do we do this int thing around the input? Because we want a number, exactly. So if we didn't have this int, the input function will ask the user to enter something. They can type whatever they want, and this int converts it to a number, because by default it's a string, right? This is the data types. By default, input gives you a string because the user can type in anything they want. So because we want it to be an integer, we convert it ourselves using the int function. However, this is where the first example of an exception occurs. And this is something we've seen in Python level 1. If you are asked to type in an integer, but you instead type some letters, you run into an error and your program just crashes, right? So I can show that in this cell right here. You can ignore the review. That's a little bit different than what I wanted to do. But in the lesson section, this first cell is exactly the code I had on the slides. So here, first, let's just run it and do what it asks, right? So it says, please enter an integer. And once it starts loading, it says, please enter an integer. I can type in, I don't know, 45. Hit enter, and if we type in an integer, it works as expected. However, if we now type in my name, maybe I don't like reading instructions. I didn't know it asked for an integer, and I just type in whatever I wanted. I type in Jack. Then our program crashes. That's the red lines. That's this error message right here. Right? It says value error. You have this output, and then you have a kind of a message. So this is what happens when you don't handle your exceptions. Right? A value error is one type of exception. And if you don't handle exceptions, it just crashes your program. Right? End of story. We have other examples of exceptions that I'm not sure if we've seen in Python 1. If we did, it was a long time ago. But this is something that you might know from math, right? It's not possible to divide numbers by 0. It's undefined, right? And so if we look at this piece of code, can anyone describe to me, maybe in a sentence, what does this code do? Really, I'm interested in the for loop. So what does this for loop do? We have a list of numbers. What does this for loop do? So, okay, I didn't understand for loops and while loops too well. Okay, so we can review for loops and while loops. I know that was a little bit quick. Does anyone else also feel similarly? Feel free. Okay, Andrew says executes a command for each element. That's correct. So I'll explain what this one does, but then I can take a few minutes to review for loops and while loops. I think loops are just very useful, and so that's why it's good to understand it well. So if we look at this example specifically first, the first line of code is creating our list, right? So this is like the second bullet in the review. A list is just a collection of items, right? So in this case, it's just a collection of numbers, specifically a collection of integers. This is the thing at position 0, index 1, so on, so on, so on, right? It's just a collection of items that has an order to them. What this for loop does, if we look at it, it says for n in x. So this n is just a variable name. So for now, like, don't worry about it too much. It could be anything. So I'm just putting a underscore, a blank there. So for blank in x, right? So x is our list. This blank is a variable name. It's basically taking on the value of everything in our list one by one. So we're kind of filling in the blank, right? So x contains these values. Our for loop basically takes each value out of the list and puts it into that variable, whatever we call it. So in the case, we called it n. So the first time the for loop runs, n will be 1. The next time the for loop runs, it will be 4. The next time it runs, it will be 8, so on, so on, so on. Right? So it takes on every single value in our list in order. Right? And then what do? We just print out 10 divided by n. Right? So the first time this runs, it will be 10 divided by 1. The next time it runs, it'll be 10 divided by 4. The next time it runs, it'll be 10 divided by 8, so on, so on, so on. And so this is where we see another problem, right? Because in our list, we have the number 0. And as I mentioned before, you can't divide 10 by 0. You can't divide anything by 0. And so when this code is run, halfway through, it will run into an exception and it will crash. So let me run this. It's just the next cell. Run this. We also get the red underline. We get some of our expected output, the ones that didn't cause any problems. But then we have our error message right here. Notice it's a different error, right? Here, it was a value error. This case, it's a 0 division error, right? So this tells us the error message actually gives you a lot of information. It doesn't just say, hey, we crashed. It says, hey, this is the reason why you crashed, right? So it really helps us. But going back to loops, let me try to open up the slides that I had on them, and we can talk about it really quickly. Here we go. For loops, while loops. This is the for loop. This is the same structure that we saw just now on the exception handling. This is looping through a list. So this, you say for x in fruits. Remember, the x is kind of your blank. It becomes different values depending on what's in your list. Right? You fill it in later. Right? When you're writing this code, you don't really know what x is. Maybe it's 5, maybe it's apple, maybe it's false. Right? It could be anything, sort of. It doesn't really matter. The idea is you're just running some sort of code a bunch of times, right? So you're just running this print statement a bunch of times. And what are you printing? You're printing out x, which is going to be everything in your list. Right? For x in fruits. The structure is for your variable name in a list, or we'll see other things that you can put here. So that's the template, right? You always have for, you always have in. The name can be anything, right? As long as it's a valid variable name, you can put it there. So it could be X, it could be Joe, it could be Bob, it could be ASDF. It can be anything. That's a variable name. This thing, on the other hand, is a little bit restricted. This thing has to be something that we can loop over. And later on in Python 2, we might talk about what makes something iterable, we call it, able to be looped. For now, we just have to know what things by default are iterable, loopable. In this case, it's a list. Lists are iterable. You can loop through them. You can also loop through strings, and you can loop through ranges. These are the 3 things that we talked about in Python 1. So lists, strings, ranges. Oops. For a string, when you're looping through a string, you're basically just going through every single letter by one. So first x is b, then x is a, then x is m, then b again, then o, and then o again. So this will print out every single letter one by one. Range is a little bit more complicated, but it's a little bit more interesting. Range, you can think of it almost like a list. It's not, so don't confuse it. But in terms of just understanding what this does, you can imagine that this range is just a list of numbers. Specifically, it's a list of numbers starting at 0, going up to whatever you put here, but not including. So here, range 10 is the exact, well, it's similar to just a list where you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the range 10 is essentially just a list of numbers going from 0 up to, but not including 10. And so this is just going to print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The next couple slides, we're just saying, hey, inside the loop, the variable is just another variable. You can do whatever you want to it. You can use it in other functions. So you can use it in the len function, which we said takes the length of whatever you pass in, right? So it's just a variable. Use it just like how you would use any other variable, right? Then we had the while loop, which again is another way of repeating lines of code. So a while loop has a condition built into it. Notice the for loop does not have any sort of condition, right? It doesn't really tell you when to stop. It just stops automatically when it reaches the end of your list or the end of your string or the end of your range, right? It does it kind of automatically. A while loop, on the other hand, you kind of provide it a condition. And you say, while the condition is true, you're going to repeat. But once the condition breaks, once the condition is false, then you just stop looping. And so here you say, while count is less than 5, we're going to repeat whatever is inside. So while count is less than 5, we're going to print it out and we're going to increase it by 1. And so you can see naturally, if you do this enough times, then the condition is going to become false, right? Because each time we increase it by 1, so eventually it's going to reach 5 and it's going to stop. We can have infinite loops though. If you remove that increment, it can go infinite, and this is gonna cause some problems with the Python program. It's just not gonna stop, but it's not gonna cause any problems to your computer. Your computer is gonna be fine if you have an infinite loop. So that's really the important things to know about loops. For loops, while loops. I think while loops are a little bit easier to understand just because it's like a little bit more clear what it's doing. It's like, while this condition is true, repeat. If it's not true, move on, right? For loops, although, are a little bit, I think, more common, unfortunately, because a lot of times you do have a list and you want to do something for each item in your list. And so that's going to look like this. That's going to look like what we had on this slide. For n in x, print 10 divided by n. If we name the variables a little bit more than just single letters, it might make a little bit more sense. The n is probably standing for a number in x, and x could be like my list. So for a number in my list, do this stuff. Print 10 divided by the number. Okay. I think it can be a little bit easier if we don't have just single letter variable names. All right. So hopefully that was a little bit useful. If any questions do come up again, please don't hesitate to ask, and I'd be happy to go over it. Especially, yeah, no problem. Especially this is the first class, but even in future classes, if something from previous weeks didn't make sense or you need a more of a refresher, I'm happy to go back. All right, so back to exception handling, just to summarize what we found. A runtime error will suspend the execution of your code. So a runtime error is what we've seen before, the value error, the zero division error. It's an error that happens when you run the program. That's why it's called a runtime error. It will suspend the execution, which means it will just stop it. Right? It doesn't move forward. It doesn't try to fix it. It just stops. What we can do is put a try except statement in your code to catch the errors so it doesn't stop, so it doesn't get suspended. And so try except statement, that's like if else statement. You're going to have a try section. You're going to have an except section. Right? And so what does that look like? It looks like this. So here, it says try, and we have some code, and we have except, and then we have some code. Notice these lines of code after the try. This is a code block. And whenever we start a new code block, we need the colon. Right? We have the colon for loops. We have the colon for if statements. It just shows you're making a section of code, a block of code. And so here we have our try block. We have try and then some lines of code. And we have except and then some code. And so what this does is it does kind of what it sounds like. We try it, right? Hopefully it works, but maybe it doesn't. We're just trying. Right? So we're trying this. We're trying x equals int input, please enter a number. And then we print string x and we break. So we're trying all of this. But if during any time we're trying this, some sort of problem happens, we can't do what we wanted to do, then instead of crashing, it will go to the except. And here it says except value error. This means if in any time in the try block, we come across a value error, then this is what we do. This is how we handle it, right? It says print, oops, that was not a valid number, try again. And notice this is all in a while loop. And so what this does, it's kind of interesting. Well, we can just run it, actually. It should be in the notebook. See here? I have a slightly different example. But again, you have a while true, and we have try. It's a little bit different because we have two excepts, but I'll talk about that now. So this says, please enter a number, right? If I do what it asks immediately, let's just say 9, or let's say 25, right? It just finishes, it says 4, because what are we doing? We're asking for a number, we're converting it to an integer, and we're printing out 100 divided by that number. So here, we enter 25, it converts it to a number, no problem. And then it prints out 100 divided by 25, which is 4, right? And then it breaks. So even though we have a while true loop, this looks like it goes infinite. As long as we have a valid input, and as long as we can divide 100 by it, it will break, so we'll stop. Right? This break statement stops the loop. So this break stops the loop. Right? But what happens if we enter a letter? What happens if I enter my name this time? Right? Will it crash? Hopefully not, but let's see. I can enter Jack, I can hit enter, and then what do we know? It doesn't crash, right? Because we handled the exception. If we enter text instead of numbers, it will say, oops, that was not a valid number, try again, right? And then it prompts me again. And so maybe I'm really stubborn and I don't want to enter a number and I try my last name. Just asks me again. I can enter letters. Oh, well, I entered a number by accident, but I can enter text for as long as I want and it will just keep asking me. It's very, very insistent that I enter a number, right? As long as it doesn't work, it will just keep asking me. And that's because of this while loop, right? Because let's look at what happens when we enter ASDF. Well, while true, we try this. We try to get some input and convert it to an int. Well, if we enter ASDF, we can try this, but it's going to fail, right? If we try line 4, then it's going to give you a value error because that's what we saw when you put text when it's expecting an integer, right? So then it goes into the value error and then it says, oops, that was not a valid number, try again. But notice in this case, we don't have a break statement. So once this finishes running, we go here, but then we're still in this while true loop. So we just run it again. We try this again. And if anything happens, we print out some sort of notification and then we try again, try again, try again, right? And so the other error that we saw was the 0 division error. But this time, if I put 0, it will just give us a different error message. But again, it will ask me, keep asking me. So let me give it something at once, and then let me just make the output a little bit smaller again. So that's your basic try except statement. You have your try, which is exactly what it sounds, the stuff that you're trying, the stuff that might have a problem. You don't know. Then you have your accepts, which is basically saying, if this happens, do this. If this happens, do that. So in a way, this is kind of like an if statement. You can kind of think of it like, if you have a value error, do this. If you have a 0 division error, do that. Right? We'll actually talk about later on. You can actually put an else. So it's not just like an if statement. You can actually have an else statement with try catch, but try except. But we'll get to that later. For now, um, do we have any do I have any questions on this general structure of a try except? A really quick note: when I say try catch, that means the same thing as try except. It just depends on the language, really. In Python, it's called try except. In Java, it's called try catch. Other languages use catch, languages use except. They all mean the same thing. I actually like catch because it that's kind of what it's doing, right? It's catching your exceptions, right? It's making sure they don't go where they shouldn't go. You're catching them and you're doing something with it. The last thing I'll note is that with excepts, you generally should have the type of error that you're trying to catch. So here we say value error. So we're trying to catch value errors here. Here you're saying catching zero division errors, right? So you should be precise and say what kind of error are you trying to handle? However, it is completely valid to have a general except. So you can just say except and then blank and then print something wrong. So you can do this. This is valid Python code. And what this does is, if it's not a value error, and if it's not a zero division error, then it will just do this. This is kind of your like default case. You know something wrong happened, but it wasn't any of these that you were expecting. So then it just falls in under this general case. Okay. This is actually kind of more common when you're just programming for fun because it's less typing. But best practice is to specifically say what kind of error are you going to catch, because you don't want to accidentally catch errors that you weren't expecting, right? Maybe you thought it could only break in this one way, and so you just have a general except. But what happens if later on someone else finds it to break a different way? Then you want to know. You want to know it's different than what you were doing before. And so that's why you shouldn't really do general. It's a little bit too generous. So again, as a recap, try statement works as follows. First, the try clause, whatever that block of code is run. It's executed, just like normal. If there's nothing wrong with it, then we just move on. We don't care about the excepts. We just move on to the next line of code and everything is fine, right? What's different though with a try statement is that what happens if things go wrong? If an exception occurs, instead of just crashing, the rest of the clause is skipped. So the rest of the try is skipped. Then if the type of the exception matches any of the exception statements that we have, then that is going to be run to handle the error. Right? Afterwards, it will just move on to whatever code you have afterwards. If an exception occurs does not match any of the things that we listed, then it's just as if we didn't have any try except, then it will just crash like before. So I can show that. If we go to the notebook, let me get rid of my general. Let me get rid of the zero division error except. So if we just have this, it will still catch the value error, no problem. It will still be fine if we enter text. But if we enter 0, this will still crash. Because even though we have a try except, when we do 100 divided by x, this throws an exception. An exception happens. We go to our excepts and say, hey, do we know how to handle this? Right? In this case, it was a zero division error. We only know how to handle value errors. That's what we say. We only know how to do this. So since it's not a value error, we just say, oh, okay, we don't know what to do. I throw my hands up in the air. I give up. I'm going to crash. Right? I think that's another way to think of try excepts. It's kind of like an instruction manual. It says, if anything goes wrong, check this. Here's the solution. Right? So if anything goes wrong here, check, oh, if it's a value error, this is how you fix it. If it's a zero division error, here's how you fix it, right? It just tells you what do you do if something goes wrong. Notice really quickly, all these are online, but you can have multiple lines of code. So you can have like another print statement. You could even have calculations. You could do anything here. It's just write Python code here. A try statement may have more than one except clause. So we saw this. You don't just have to catch one exception. You can accept multiple of them. So you can have different handlers for different exceptions, which is what we have right here. We have one handler for value error, and we have another handler for zero division error. Another way to do it is you can actually have one handler for multiple exceptions, and that's what it looks like right here. So you can have one handler, one except statement for multiple different errors. So you can say except value error and an IO error, for example. We don't know what IO error is yet, but this would handle both of them in the same way if it happens. You put them in a parenthesized tuple. So all that means is you have parentheses and separated by commas. The last except clause may omit the exception name. And so this is what I was talking about for the general except clause. Let me just check. No, yeah. So use this with caution, like I said, because you can run into things that you don't want if you use this too much. Because you don't really know what exception happened, right? Because it's a general, it accepts all sorts of different types of exceptions. You don't really know what went wrong. So you should be careful when using the general except that doesn't have the exception name. Here's another example similar to what I had on the slides. The code in the try is just Python code. You don't have to know how it works, but it's just messing with the file system. And this code can have exceptions some of the times. And so here we say, if we have an IO error, do this. If we have a value error, do this. Otherwise, if we have an error and it's not one of these, do this last thing. Right. One comment I will make really quickly. Only one except statement will be run. So we'll see why this is important very, very soon. Well, actually going to see it right here with the built-in exceptions that are included in Python. And so here I have, I think, 3 slides of all the different built-in Python exceptions. And so please do not memorize this. There's no real reason to like memorize this, but it's just good to know what's out there. And so here, we'll see why this is organized later on in Python 2, but in general, you have your base exception. So everything comes from there, right? Within the base exceptions, you have these ones: system exit, keyboard interrupt, generator exit, and then exceptions. Under exceptions, you have more types. You have stop iteration, you have stop async iteration, you have arithmetic error, you have assertion error, you have attribute error, buffer error, EOF error, import error. name error. So actually, there's a hierarchy to them, right? So there's kind of a top level, and then it goes more and more detailed, right? So you have your base exception. Within your base exception, you have the general exception. Within the general exception, you have arithmetic errors. Within arithmetic errors, you have zero division errors, right? So it's kind of organized. And it just goes on, right? So we saw the zero division error. That's what we saw in the code before. Let me check. You have value error right here, and then you have a couple more. And at the end, you have warnings, right? All of these can be caught using try except. I think a clearer way to see it is like this tree structure. So here's like a picture I have in my notebook. We have your base exception. Under there, you have exception. Under exception, you have arithmetic error. Under arithmetic error, you have zero division error. Right? So you kind of just work your way down the tree. And so you can have an except statement for arithmetic error. You can have an except statement for zero division error. But you have to be careful here because only one except statement is run. And so if you have an except for arithmetic error and you have an except for zero division error, you have to be careful because zero division errors are an arithmetic error. So if you have an except for arithmetic errors, it will catch all of these because all of these are arithmetic errors. Right? And so I think I have some code right here. So here in example 1, we do print 5 divided by 0, except zero division error, except arithmetic error. And so if we run this, it will say divide by 0 because we go through our excepts and we say, hey, what happened here is a zero division error. So we print out this error message. However, if we swap our excepts around, so this next example is almost identical to before. The only difference is that we've moved our except statements around. Now if we run it, it prints out something different. It prints out arithmetic error. Why is this? Well, if we trace through the code, we try to print out 5 divided by 0. This has a problem. It has a zero division error. So we look through our except clauses. The first one that we see, we go top down, is except arithmetic error. And Python goes, hey, I have a zero division error. That's exactly an arithmetic error. So good, I know what to do. I go inside, I print out what it tells me to do. And then since you only do one except statement, you just stop, you just move on, right? You don't say, hey, it falls under both categories, so I'm gonna print out both things. It doesn't work that way. We go in order and we only do one. And so that's why the order of your except statements does matter. And that's why you can only have the general except statement at the very end. Because if you had it at the beginning, then there's no point of having anything else because any exception is going to fall under that bucket, and then it's just going to do that, and then it's going to skip everything else. Right? So you always need your most general excepts at the bottom. By the way, just a note, this is not something that will cause your program to have crashes. This kind of bug is just going to have your program do not what you want it to do. That's kind of the worst kind of bug because it looks like it might be working, but then you realize later on, hey, it's actually not working. It's actually kind of blowing up and not doing what I want it to do. So be careful here. Kind of the last things I wanted to cover today is some sort of add-ons that you can put to try except. So try except is kind of your bread and butter. It's your default. It's what you're going to use always, right? If you have a try, you need an except. They go together all the time. However, you have an additional couple things that you can do. You can put an else clause. And the else clause just goes after the excepts. And basically, it's like the opposite of except. So excepts are run when an error happens. The else clause runs when there are no errors. So if it's present, it is executed when no exceptions are raised. So if we look at this diagram, this is what it looks like now. We have try, we have except, we have else. In try, we just run the code. We just try it. Then if an exception happens, we execute this, right? Execute this code when there's an exception. And then if there are no exceptions, we run this code, right? These are exclusive. You can't run both, right? Because you can't have an exception and also not have an exception at the same time. But this is a way to tell if your program ran successfully or if it ran into an errors. So that's really why the else clause exists and what it's useful for. Similarly, another kind of add-on that you can put to try excepts is the finally clause. So this also goes at the end. It goes after your excepts. And instead of having some sort of condition, it's always executed. Doesn't matter what happens above, it's always executed. And so that's the cool thing about finally. And really the only thing that you need to remember about it. It always runs. Unless your computer like shuts down or something in the middle of your program. But it doesn't matter if an error happened. It doesn't matter if the error was handled or not. Even if your program is going to crash, it makes sure to do the finally before it crashes, right? And so why is this useful? Well, in some cases, you want to make sure that you kind of clean up after yourself, right? You can imagine if you're working with files and you're creating a new file, right? Maybe you're running some sort of calculations and you're writing the output to a text file. And then halfway through, you realize, hey, something went wrong. I can't continue. Well, you might not want to leave like a half-finished file on your computer. And so in the finally clause, you can just say, hey, clean up, right? If the work, I just close the file, I delete it, make sure everything's clean, so there's nothing left next time I run it, right? That way, it doesn't matter, it's always gonna run. So this is kind of the full picture, right? With everything put together. You have your try, you have your except. These are always there, right? They go together. You can't have one without the other. So again, you just run whatever in your try. If an exception happens, you look in your excepts and you see if there's a valid except statement that matches whatever went wrong, and you run it. If nothing went wrong in your try, you run the else. Then doesn't matter what happened in your try, doesn't matter what happened in your except, doesn't matter what happened in your else, you always run finally. It's always run on the way out. So that's kind of exception handling in a nutshell. Just gotta know try except and the different sorts of exceptions that exist in Python. I will say value error and arithmetic errors are probably the most common that you're going to see for now. But actually, another one really quickly is out of bounds errors. So if we just go say like my list equals the list like A, B, C. If we try to access something that's out of bounds, let's say my list 10, There's definitely not something at index 10. If we run this, we get an index error. And so this should be on our diagram. Our diagram's up here. Index error is over here. It's under the category of lookup error, and it's under the category of exception. So just like how you have to be careful with arithmetic error and zero division error, you have to be careful with lookup error and index error. For else and finally, I do have some code on the notebook to just show off what it's doing. So here I say, I hope nothing goes wrong. And I ask for input. And I try to print out 10 divided by x. This looks similar to what we've seen before. If any exceptions happen, I just say an error happened. If nothing happens, if no errors happen, I say, phew, everything went well. And then no matter what, I will always say, I have finished executing. So just to show this in action, I run this. It says, I hope nothing goes wrong. And let's just be nice. I enter a valid number. It says, phew, everything went well. And it finishes. If on the other hand, I enter something that doesn't work, then it just tells me an error occurred. But even though an error happened, I still do the finally. I don't skip it. I still say I finished executing. For the notebook, I do have other sections, but they're kind of niche and not super important. So I'm not covering them in class today, but feel free to take a look. There's a way to create your custom exceptions. And there's a way to kind of raise your own exceptions. So this is like if you want to manually create an error, this is what you do. I do have a couple multiple choice quiz questions to finish up for today. And then I'll go over the homework and then we'll be out for 7 o'clock, hopefully on time. But just here's a multiple choice question. How many except statements can a try except block have? Is it 0? Is it 1? Is it 0 or more? Or is it 1 or more? Andrew says D. Any other answers? Thank you, Jonathan. Thank you, Andrew. D is the correct answer. So mentioned before, you always have to have one except statement. Right? You can't have except without a try, and you can't have a try without an except. So you always have to have at least one. But how many you have is completely up to you. You can have infinite of them, or as many as you can put on your computer, of course. This is kind of just here's some code. I'm gonna run it, what happens? So I say try, print try, accept value error, then I print value error. And I say finally, print finally. So don't worry about the white space. You can assume that the text is going to be formatted correctly. So don't worry about the formatting. But does anyone want to tell me what is the answer to this question? Let's see. It's been a little bit of a quiet class. Let me call on someone. Andrew says D, but maybe Alex? Let's get a new voice in here. Alex, can you tell me what is the answer to this question?
let's see. I think it's, wait, can I read it first?
Yep, no problem. The italics is a little bit just random. That's not.
I think, wait, hold on.
Let me just format this on italics.
I think it's D.
Yep, so that's the correct answer, but can you tell me why it's D?
Because it says, the first thing it says print try, right? And the accept.
Yep. Oops. Yep.
And the accept. So it kind of, to me, it's like, to me, it's just like I remove those two, and then I just the value error removes itself, and there's only try and finally in a way. Well, that's how I explain it.
Yeah, so that's about right. So you can kind of just ignore these two lines of code in this case. You can delete this. It doesn't really matter. Although you have to be careful, why can we ignore this? The reason we can ignore this is because there's nothing in my try catch to throw an error, right? This doesn't cause a value error. And so because this doesn't cause a value error, this accept isn't run. It's just like an if-else statement, right? For an if statement, if the condition isn't met, the code isn't run. It just skipped. And so here, it's kind of like an if statement. The condition is having a value error. Well, we don't have it, so it's just skipped. So that's why it's D. So that's it for the quizzes. So just going over the homework really quickly. As a reminder, the homework for Python 2 is going to work basically the same as Python level 1. So complete it wherever you want, whenever you want during the week, submit it to Google Classroom, and I will leave some comments before class the following week. I would say try to get it done maybe by Sunday, just so I have time on Monday to go over everyone and not have to worry about new responses coming in. But for this week's homework, it's just practicing writing try except statements. And so I want you to write a Python program that takes in two numbers from the user. So all the examples we've seen before just take in one, but I want you to take in two numbers. So after you get in two numbers from the user, I want you to convert them to integers and store them into variables x and y. Maybe the first number is x, the second number is y. Then print out the result of x divided by y. But where the try except comes in is number 4. You need to add except statements to handle any errors that might occur during the code execution, as well as else and finally statements. So the error handling can just be some notification messages. You can just print something and that's it. It doesn't have to be very detailed. But I want you to write some excepts. I want you to write an else and a finally, and of course the try. As a hint, you're going to need 2 except statements. Just what are the errors that we've covered today, and they're the ones that you're going to need to handle for this homework. That's all I had. Last thing is just Google Classroom. Let me get on there now. I think this is it. So the slides should be posted soon, but here is the Google Classroom code. It should have been already sent out to you, but make sure to get into Google Classroom if you aren't already, and everything, as always, will be posted here. With that, thank you for coming to the first class of Python Level 2. That's all I have. So I'll see you all next week if you don't have any questions. And if you do, I'll be sticking around to answer them.
Thank you.
Yep. Thank you.
Hi, Jack, you're here?
Yeah.
Oh, sorry. Jason, are you still here? Let me stop recording.